live. Okay, so review date 10/10/19. So number one says graph. It is technically a point on the imaginary plane. So the imaginary plane looks something like this. Okay? You have your real axis. We talked about this a couple of weeks ago. And we talked about this 2 weeks ago, but it was homecoming week, so you've forgotten this, of course. And you have your imaginary axis. So this is actually a point. You go 1, 2, 3, 4, 1, 2 for the eyes, and you have a point right there. That's it. It's that easy. That is just graphing an imaginary point on the imaginary plane. You've got your real axis, which is your 4, your imaginary axis, which is your -2. Thumbs up?
Wait. Yeah. And why is there an eye?
So the eye comes from, we're going to graph this point, which is imaginary. So you can't graph an imaginary number on a regular graph. It has to be on the imaginary plane. It's called the imaginary plane. So this is my eye-axis, okay? And this is my real axis. That's a real number, right? 1, 2, 3, 4 reals. And then -2 eyes. -1, -2. That's the one right there.
Okay.
Okay? Really not that bad, is it? Okay? Let's look at number 2. Number 2, we just add eyes with eyes. This should be easy. Let's see. What is it? 21. And then plus 11i. Right? That should be easy. Number 3, we just have to remember if we're subtracting. This is my method. You don't have to do my method. For me, I make mistakes all the time. So I bring through the negative. I change it to plus. And when I change it to plus, then I bring through my negative. Makes that a -5 plus a 14i, right? And then I can add reals with reals, -22. And then I end up with, if that's a 1, a positive 13i. Okay?
Wait, so did you foil?
I didn't foil at all. No, great question. Because that's a subtract. I just subtracted. So -17 subtract 5. So -22. And this is where I have to be careful in. And I go -1 minus a -14. Minus a -14 is like plus a 14.
Wait, so negative.
So I got my double negative, right? I just made sure I didn't make a mistake
Plus
with my
what?
plus
You
14.
do it over?
Yeah. Yeah. So I get a -1 plus 14 because it's a minus a -14, okay? Now 4 I'm going to have to foil, okay? And I know it's a foil because there's nothing in between, right? So let's do it. 13 times 10 is 130. 13 times -2i is a -26i. -2 times 10 is a -20i. -2 times -2 is a positive 4i squared. Okay, how am I doing? My I squared I'll make into a -1, and I'll combine these two middle terms, okay? So I'm going to have 130 minus a 46i minus 4. And I'll slow down for a second. I squared is -1, which makes this number -4, right? Yeah. And now I'm going to finish it up and put my reals together and have an answer of 126 minus 46i. Okay. I to 35, we all already talked about it, but if you want to put on your side on the column here, I is just I, but I squared is -1, I cubed is a -I, and an I to the 4th is positive 1. That might help you with number 5, okay? And then the pattern just repeats, right? Every 4, the pattern just repeats, okay? So I-35 can be rewritten as a multiple of 4. You want a multiple of 4, so it's I-32 times I cubed. And the reason I want to do that is I-32, the number 32 is a perfect multiple of 4, which makes a bunch of 1s. In fact, it makes 8 1s, and 1 times 1 times is so 1. So this is the number 1 times I cubed. So I get I cubed, by I cubed we saw was negative I. It's negative I.
That's the answer?
Wait, no, wouldn't it be 1 minus?
It's going to be a 1 times I cubed. I could put a 1 here, but okay, it's going to be a 1. You okay with the number 1?
Yeah,
And then I cubed. What is I cubed?
negative I.
Yeah.
So would the full answer be 1 minus I?
How about a negative 1I? I'll put the 1 in there if that helps you. Because you got 1 times. This is 1 times negative I, which is a negative 1I. Okay? And you don't need the 1, but I'll put it in there anyway, okay? The 1 will help. Want it? Okay, 6. All right, 6 I'm going to multiply by the conjugate, right? Multiply by the conjugate, we're going to go 2 plus 3I, 2 plus 3I, okay? And then when I multiply through, I will get a 6.
Okay, scoot over a little bit.
I sure can, Zoe. 6 plus a 9I, plus a 10I, plus a 15I squared. In the denominator, I'll get a 4 plus a 6I minus a 6I minus a 9I squared. How am I doing? Let's tidy up a little bit. All my I squareds are going to be negative 1. So this I squared here and this I squared are going to be negative 1s, right? So I'm going to have a 6 plus a 19I minus 15. And I got the minus 15 because my I squared is a negative 1, which makes that a negative 15. Okay? And in the denominator, the reason we do the conjugate always works is because it always will cancel out the middle two terms. So I'll be left with a 4 plus 9. And the reason I got positive 9, yep. I squared is negative 1 times negative 9 plus 9. And then 13 is correct. So I'm going to wind up with a, it's at a negative 9 plus 19I over 13. But I really should write this as negative 9 thirteenths plus 19 thirteenths I, okay? Because it is supposed, I won't count that wrong, but it really is supposed to be written as 2 parts, real plus imaginary, okay? And they would mark that wrong in math at school. So if you do math at school, they would mark this wrong. You have to have it I plus, or get real plus imaginary, okay? All right, 8, I'm going to need a separate sheet of paper because I'm going to have to use the quadratic formulas, okay? So let me slide 7. Let's do, 7. Yeah, I'm going to need extra paper for 7 anyway, okay? So I'll do number 7 on a separate sheet of paper. Do you guys want to grab a separate sheet of paper real quick? Okay. X to the 4th plus 7x squared minus 144 equals 0. Okay. So I've got to solve. Let's see, 144. What are the multiples of 144? I'm not sure yet. 144 divided by 12 and 12, but 12 and 12 is not going to work.
Negative 12 and 12.
6 and 24? No. Let's try another one. 144 divided by 8 and 18? No. 36 and 4? It's got a factor. 144 divided by... Well, hold on. Let's look at all the factors. Okay. 12 and 12. 3 times 2 times 2. 3 times 2 times 2. I could have... You need to make a 7, don't I? 9 and 16. Do you see how I got it? See, I did 9 and 16. See, I did that? There is, you guys learned this stuff way back in middle school, and what do you know?
The factor tree?
Yeah, and it worked because I got it. I got 9 and 16.
I know.
You saw I got it, isn't that cool? 9 and 16. So x2, my bad. x2, what do we say? A 9 and 16, right? Positive 16, negative 9. Mini equations, x squared minus 9 equals 0, and x squared plus 16 equals 0, right? X squared equals 9. How many answers?
2.
Yep, squared, I get plus or minus 3. There's my first two answers, right? Minus 16, squared, how many answers?
2.
And I'm going to get an I. And if you don't see the I, it's going to be the square root of 16 times the square root of negative 1, right? Which is x equals plus or minus 4i, right? 4i. But two answers is correct. There are two answers. It's 4i and negative 4i. Right? Thumbs up? Okay. Okay, turn the page. Kind of, sort of. Not really turn the page. I'm just going to do the next one. Quadratic formula, okay? Negative b, right? Negative b plus or minus square root of b squared minus 4ac all over 2a. A is 2, b is negative 3, and c is 7, right? So, you ready? Negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 7 all over 2 times 2. Okay? Just plug them all in. Mr. Massey's going to make you do this. So, positive 3 plus or minus square root of 9. Oh, let's see. 8 times 7 is 56, right? Minus 56 all over 4. 9 minus 56 is negative 47. 3 plus or minus the square root of negative 47 over 4. I like that answer because it's a prime number. I can't break it down. That's why I like it. I mean, we're going to make it an I, okay? We're going to make it an I for sure. But the square root of 47 doesn't have any multiples. 47 is a prime number. So it's going to be 3/4 plus or minus the square root of 47i over 4. Yep. So there is 47 is a prime number. So I can't break it up anyway. But I see the I in there because it's the square root of a negative. So I definitely have the I. I broke it up into two parts. So I have a real plus and imaginary, okay? Okay. Turn the page. I'll wait for you, Landon. Okay. All right, number 9. Let's factor. So number 9, I'll do on a separate sheet of paper also because I need room. I'm going to go 2x cubed minus, and put a 1x squared here because it's going to help me, minus 2x equals negative 1, okay? Well, I've got to make it equal to 0, so I've got to bring the negative 1 over. So I'm going to bring the negative 1 over by adding it, and I have to put it in order, so I'm going to put it right there, okay, in order. So rewrite this as 2x cubed minus a 1x squared minus 2x plus 1 equals 0. Okay, that's the first thing I did is get them all together. And I'm going to group. Do you see the grouping? 4 terms, right? X cubed. I'm going to group. So let's group them. Let's put the first two together and the second term together. So if I group them, these two have a x squared in common, which will leave a 2x minus 1, right? These two don't have anything in common, but let's take out a negative 1, okay? So if I take it out a negative 1, it changes their signs and makes it so that I have the two groups have something in common by taking out the negative 1, right? So if I take out the negative 1, I definitely have something in common between the two groups, which is my parentheses 2x minus 1. If I take that out, I'm left with an x squared minus 1. How am I doing? Now it's just mini equations. It gets pretty easy, doesn't it? So into my mini equations, we'll have a 2x minus 1 equals 0, and an x squared minus 1 equals 0, right? We're going to solve. Plus 1 divided by 2. The first answer is a 1/2, right? Plus 1 divided by 2, 1/2. Second one, we'll get x squared equals 1. Two answers, right? Two answers. Square root. We'll get x is equal to plus or minus the square root of 1, which is just 1. And there's my three answers. Okay, number 10. It's kind of sloppy because I drew it, but it has zeros. It has x-intercepts or zeros at x equals -1 and at x equals 2 twice. Okay, so I'm going to write it twice. Okay with that? And I'm probably going to use a separate sheet of paper because I'm going to need a little bit of work here, okay? So it happens twice. That's a double root. Remember we talked about that, being a double? I didn't draw it very well because it's sloppy, but it touches it and goes, okay? So, how do I get a -1? Well, the equation is x plus 1 mini equation would give me an answer of -1, right? X minus 2 would give me a mini equation which would give me a positive 2, but this happens twice, so I'll put another x minus 2. I can even write that as x minus 2 quantity squared, right? Which I might. Now, there's some number a that specifically makes this shape. A is probably going to be positive the way it ends, right? Well, let's find the value of a. So I need another point besides these. My other point is this point here at 0, 3. So I've got my point at 0, 3, which has a x and a y value, right? X, y. I sure will. There we go, Zoe. Okay, so x, y. So I'm going to plug in 0 for all my x's. I'll plug in 3 for my y, and I'll find the value of a. It's really not that bad, is it? So I go 3 equals a times 0 plus 1 times the 0 minus 2 times the 0 minus 2, right? Just plug in 0 for all my x's. I plugged in my 3 for my y's. I'll have a times 1 times -2 times -2. That's a 4, positive 4, right? So I'll have 3 equals a times a positive 4. Divide, and I get a is 3/4, right? So here's my answer, and I will rewrite it. So if that's the a, then that really is going to go right there, and that would be my answer. I'm going to rewrite it out, but my answer is this equation. Y equals 3/4 times x plus 1, and to shorten it up, I'll go x minus 2 squared. You don't have to do the quantity squared, but for me it's just shorter, faster, because it does happen twice, right?
We're getting synthetic division.
Yeah, synthetic division. And we like synthetic division, right? Okay, whisk that away. Did I take that away too fast?
Yeah.
Okay. And we'll do synthetic division in just a second, okay? Okay, when I get done recording, will you guys remind me?
Yeah.
So you turn it off, Mr. Davis? Okay. Okay, whisk it away. Okay, 11. Let's do synthetic division. So I'm going to go -2, right? Into a 2, a -3, a 0, -2, and a 5. Now the 0, where did this 0 come from? Yeah, there's no 0. There's a 0x squared. You have to have that. Have to have it because you need to have a place value for that. Okay, here's my adder line and my remainder, right? First step, bring down the 2. 2 times -2 is -4, right? And add, I get a -7. -7 times -2 is a positive 14. And add. 14 times -2 is a -28. Add, and I get a -30. -30 times -2 is a positive 60. and add. So I might ask something crazy like, is it a factor? No, because the remainder is not 0, right? So, but my answer is in terms of x's, because the problem is with the x's are invisible. Let's bring back the x's, right? So my answer is going to be a 2x cubed minus a 7x squared plus a 14x minus a 30 plus a 65 out of x plus 2. That's pretty easy. You guys can do that tomorrow, right? Synthetic division's easy. Okay, are you ready? You ready? Turn the page. Okay. All right. The inverse equation. Again, I'm going to start working on a separate sheet of paper because I'm not going to have room for this, okay? So number 12, I'm just going to put here, and I've got a y equals a 2x minus 5 over a 3x minus 2. Okay, so inverse, right?
Can you switch it back?
I sure can. So to get an inverse, y's become x's and x's become y. Bye, Emma. We'll see you tomorrow. So let's rewrite this as x equals a 2y minus 5 over a 3y minus 2. Okay? Switch the x's and y's. Okay? I'm going to cross multiply. There's a 1 right here, but basically when I say cross multiply, I'm just going to take the 3y minus 2 and I'm going to multiply it up. Okay? Basically I'm cross multiplying, but the 1 here is pretty redundant, right? So if I cross multiply, I'll have an x times a 3y minus 2 equals a 2y minus 5. Okay, now, if I need to solve for y, I've got too many y's. I've got too many y's, and they're all over the place. So let's simplify and see what we can do. I get a 3xy minus a 2x equals my 2y minus 5, because I distributed, right? Again, I've got too many y's. So let's get the y's together so I can solve for the y's. So what I'm going to do is, you want to get the phone? No? Okay, all right. They can wait. I'm teaching and recording, okay? Bring that one there. It's probably for Emma, and that one there, okay? Right? So I'm going to put the y's with y's and x's with the x's. So this one comes over, 3xy minus 2y, right? So bring it over, subtract it, equals a 2x minus 5. I brought over the 2x. I'm getting close because I got the y's at least together. So I have to solve for y. Again, I have too many y's, but at least I have them on one side. So I'm going to common factor, right? So if I common factor out a y, I'll have a single y. Y times 3x minus 2 is equal to 2x minus 5, right? Almost there. I can solve for y now because I'll divide by 3x minus 2. I'll divide by 3x minus 2, and I have my inverse. So I'm going to say f inverse, because that's what it really is the inverse, is equal to a 2x minus 5 over 3x minus 2. Thumbs up? Okay, we're getting there. Okay, 13. I'm going to grab a piece of graph paper to do 13. Excuse me, Ben, sorry. Grab a piece of graph paper. So I want to do it a great job. Okay? Mm-hmm.
That's the same exact
What?
2x minus 5, 3x.
Wow, that's weird. It's its own inverse. That'll happen every now and then.
Wait, what the haystacks?
I bet if we graphed it, we'd see that. Mr. Daly.
Can I steal her for just a second?
Yes, you can. Yep,
Should
yep.
have answered the phone.
I know, I should
Hey,
answer the
what's that
phone.
look on your face?
What?
Go slower, Mr. Davies.
Okay.
Got him in?
Yeah.
Good.
Yep. Wow, I wonder what that looks like. That's a good observation. So sometimes, like, okay, real quickly, if I do this one, I know 1 divided by x, right? And if you rotated that over that line, y equals x, it's its own inverse, right?
Yeah.
So this must be one that's its own inverse. Let's check it out, okay? 2x minus 5 divided by 3x minus 2.
Shut up. No. He just sang when he did that.
Huh. So if you put the line right in here. Yeah, you know what, Jaden, you saw something really pretty unique. And I know I'm recording, but if I were to take this line right here, it flips right onto itself, doesn't it?
Yeah.
And with rare occasions, some equations are their own inverses. This is one of those examples. So it's own inverse.
We need to have one of these.
Yeah, you have one of these, but I don't think it's its own inverse. But good observation. And we just proved it, didn't we?
Yeah.
Yeah, pretty cool. Okay, they don't all work that way, right? But that one did. And it proved that it's its own inverse, didn't it?
Yeah.
Okay.
Came up with the same answer.
So it's got to be its own inverse. Okay, 13. Here we go, Landon. 13. We're going to graph f of x equals 4 minus 3x squared from 0 to 2, okay? All right, and I'm going to try and do a really good job graphing this. That's why I got graph paper out. I'm going to try and be accurate, okay? So I'm going to put down my XY axis. I'm going to graph 4, 1, 2, 3, 4, 0, okay? And you could put this on a calculator. I'll show you that in a minute too, but I'm going to just do it in my head because we can. It's going to be upside down parabola 3 times as tall. It's going to be an upside down parabola 3 times as tall. So normally I go 1, 1. But I'm going to go 1, 3. Normally I go 2, 4, but I'm going to go 2, 12, okay? Because I'm going to go 3 times as tall. So 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and that's all the further I'm going to do, this parabola. I'm going to stop there. I'm going to stop there because that's all I want. Okay, now, if you're really having a difficult time with this, then we can always graph it and use a table, correct? Remember how you do the table? You can say, oh man, Dad, Mr. Davies, I get you're smart and, good for you, but I can't do this. But you can go, and then I didn't graph the back half, but if you need the points, you can go to your table, right, and go to my table, and we get all the points from the table, right? Here's my points. I can just do a dot to dot from my table. Yeah, Zoe?
What is the 0, 2?
So the 0, 2 is this. I graphed 0, I graphed the 1, and I graphed a 2, and I stopped, didn't I? Okay. So the inverse is going to be only from 0, 2 also, but the inverse is the opposite of all these points, right? So this is at 0, 4, its inverse is at 4, 0, okay? So I'm switching the points. This point's at 1, 1. This point's at 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So this point's at 2, negative 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 2. Okay, we've done this before. Here's my inverse graph. I will. So the easiest way to do it is take these points, switch the x and y's, right? And graph the switch points. So here's my inverse function. I just took 0, 4, I made it 4, 0. 1, 1 is still 1, 1. And then 2, negative 8 becomes negative 8, 2.
You mean 2, negative 12?
Is it 12? No, 1, 2. Oh, from the coordinate point. I did go down 12, yes, but the coordinate is negative 2, negative 8. Right? Okay, now we've graphed it. What else do we have to do with it? I think we have to come up with an equation, don't we? Okay?
Wait, hold up, we have homework tonight?
Maybe. I said maybe. I said maybe. Okay, so let's see what the inverse equation is. Y equals 4 minus 3x squared. How do I find the inverse equation? Switch them. X equals 4 minus 3y squared, right? And then what do? Let's solve. Minus 4. Okay.
There's on the first number.
13. We're still on 13. Right? Divide by negative 3, which makes a negative 1/3 x plus 4/3 square root plus or minus, but not plus or minus because we already made it just the plus. So my inverse equation is Negative 1/3 x plus 4/3 is equal to my f inverse of x. I probably would have written it a little differently, but that's okay. I probably would have written this 4 minus x over 3. I like that answer better, but you know, this will work. Okay, thumbs up. All right, 14, when you're ready. Because Mr. Daly told me to slow down. How am I doing?
He was joking.
It's true. If I go too fast, nobody learns, right?